Alright, let's look at example 2. It says, in order to perform arthrosclerosis research, epithelial cells are harvested from discarded umbilical tissue and grown in a laboratory. A technician observes that a culture of 12,000 cells grows to 5 million cells in 1 week. Assuming that the cells follow the law of uninhibited growth, find a formula or function for the number of cells n in thousands after t days. So we're first going to write down just the generic equation for uninhibited growth. N equals n sub 0 e to the kt. N sub 0 is your initial amount, n is the amount after time, k is your growth or decay factor, and t is time, and in this case time is in days. So our initial amount, it says that 12,000 cells grow to 5 million, and so we know that n sub 0 is equal to 12. Remember, this function n is in thousands, so if we have 12,000 grows to 5 million, I don't want to put 5 million, I just write down 5 million. So 5 million is actually, if I cross off the 3 zeros, that would give me 5,000 thousand. So n sub 0 equals 12, and n is going to be 5,000. E to the k, we don't know k, we're going to try and find k. So because the 12,000 cells grows to 5 million in 1 week, t is 7. I'm going to divide each side by 12. I'm not going to do any of the arithmetic until the end. So I have 5,000 divided by 12 equals e to the 7k. I'm going to take the natural log of each side, giving me the natural log of 5,000 divided by 12. The natural log of e to the 7k is just 7k. I'm going to divide each side by 7. And k will evaluate on our calculator. I'm going to take the natural log of 5,000 divided by 7, close it, and then divided by 12, and close the parentheses, and then divide by the 7. And I didn't specify here, but I should have, let's do this to 5 decimal places. So k is going to be equal to 0.86176. 86176. Okay, and we were asked to find a formula or function for this, and so now we have n is equal to n sub 0 is the initial amount, and that is not going to change. For this particular scenario, the initial amount is 12. Be e to the 0.86176t. And now I can use this formula to answer any questions I would like. You could also write it in function notation and say n of t is equal to 12e to the 0.86176t, okay, since n is a function of time. So the last two examples were examples of exponential growth where your constant was positive. And now we're going to look at an example where we have exponential decay. This is a radioactive isotope. So we're going to look at this example. Example 3. We've got iodine-131 is a commonly used radioactive isotope used to help detect how well the thyroid is functioning. Suppose the decay of iodine-131 follows the model for exponential decay, and the half-life of iodine-131 is approximately 8 days. If 5 grams of iodine is present initially, find a function that gives the amount of iodine n in grams t days later. And when you're finding k, we want to find it to 5 decimal places. So in order to answer questions about this function, the first thing we need to do is find the actual function. So in order to answer questions about iodine-131, we first need to find the function. So we start by using the given information that the half-life is approximately 8 days. So what that means is that if I start with n sub 0 equals e to the kt, I'm going to have after 8 days I'm going to have half left. So if I have n sub 0, then I'll have half of n sub 0, e to the k times 8. Right? Now, when we talked about money and investing and compound interest, we didn't have to write the initial value and then half of the. We could have had 5 and then half of 5, or 10 and then half of 10. But just generically, what's going to happen is this is going to be 1/2 is equal to e to the 8k. If I want to solve for k, I would take the natural log of both sides. The natural log of e to anything is that exponent, so I have the natural log of 1/2 equals 8k. Divide both sides by 8. We'll pull up our calculator. Take the natural log of a half, or you could use 0.5. Divided by 8, we get negative 0.08664. Now I have my model. I have n equals n sub 0 e to the negative 0.08664t. Since we were asked to base this model on an initial amount of 5 grams, we're not going to use this generic of a model. We're going to write n equals the initial amount 5 e to the negative 0.08664t. And it makes sense that k was negative because this is a decay model. We started with a larger amount, ended up with a smaller amount, and your k should be negative. Alright, the voltage of a certain conductor decreases over time according to the law of uninhibited decay. If the initial voltage is 40 volts and 2 seconds later it is 10 volts, find k to 5 decimal places, and does the sign of k make sense with respect to the application? So remember, in order to come up with a model to describe a certain scenario, we need to use the given information to find k. So we start off by writing our equation down. N equals n sub 0 e to the kt. We know that the initial value is 40, and after 2 seconds later it's 10. So the 10 is in here, e to the k times 2, and in this case t is in seconds. We're going to solve for k by dividing each side by 40, so we would get 1/4 equals e to the 2k. At this point you may have done enough to realize that k is going to equal the natural log of 1/4 divided by 2, and you could certainly take a shortcut, or we can do the math out. So we're going to take the natural log of each side. I may just turn the 1/4 into 0.25 because it's easier to deal with in your calculator. Equals the natural log of e to the 2k. The right hand side now just equals 2k. So the natural log of 0.25 equals 2k. Divide each side by 2. Natural log of 0.25 divided by 2. We get negative 0.69315. So our model would be n equals n sub 0 e to the negative 0.69315t. And since we're going to be answering questions about this initial voltage of 40, we're going to make our model a little less generic. Our initial value is 40, so to be n equals 40e to the negative 0.69315t. And now we can answer questions. So part B, find the voltage after 5 seconds. So I plug 5 in for t, pull up my calculator, 40, second function natural log, so I've got e to the, remember a lot of you will need parentheses here, so it would be negative 0.69315 times 5, and then close your parentheses and hit enter. So n is approximately 1.25. And to answer the question, does the sign of K make sense? Yes, if you started with 40 volts and you ended up with 10 volts, this should be a decay model, and so your constant should be negative. And then also after 5 seconds more, we have 1.25 volts, and so again, still the amount of volts is decreasing. So in summary, if you're given a model, an exponential growth or decay model with all the information already in it, you can answer all sorts of questions about how long will it take for something to grow to a certain amount, or if you know the time, you can find the amount after time. But if you don't know the model, they always have to give you enough information to find the model, and so they'll give you some initial amount and an amount after time, and you have to plug in and find K. And once you find K, you write the model, and then you can answer questions about that model. All right, and you'll be given plenty of opportunity to practice these types of problems.